elevation of the crust, more than 1000 meters, 1000 मीटर पेक्षा जर त्या एखाद्या क्रस्टचं एलिव्हेशन असेल तर this elevation is called as a mountain. If the elevation is more than 1000 meter, then it is called as a mountain. But if the elevation is less than 1000 meter, then you can call them hills or hillocks. Okay, small hills or hillocks. Okay, is smaller than 1000 meter. Now these mountains have different orogeny, means formation process of these mountains is different, not similar, and based on that these mountains are divided into different based on their genetic classification we can divide these mountains. For example, volcanic mountain, fold mountain. Okay. Fold mountains are also called as a true mountain. True mountain. Fold mountain are also called true mountain. Third, block mountain. Block mountain. Fourth, residual or relict mountain. Fifth, escarpments. Okay, escarpment. So these are the 5 types of mountains that we are going to see today and how they are formed. Okay. There are theories that like how fold mountains are formed. There are different theories. For example, we have continental drift theory of Wegener or plate tectonics theory. Okay, so these are modern theories. These theories we will look later on. But at this moment, we will just understand what are these fold mountains, what are these block mountains, and how they are formed. Okay, let us see one by one. First, volcanic mountain. Volcanic mountain. Okay, now volcanic mountain is the feature. Now this feature emerged because of some process. That process is called volcanism. Okay. This volcanism process leads to formation of some mountain-like structure. This mountain is called as volcano. Okay. This feature is volcano. The process is volcanism. Okay. Now, why they are formed and all that we will look in much detail. But at this moment, we will just understand why this happened. This happened because from the Earth's crust, because of some reasons, this is Earth's crust. Because of some reasons, inside of this Earth's crust, there are magma chambers. Magma chambers. These magma chambers are nothing but the molten rocks. Okay. These molten rocks are there inside the Earth's crust. Okay. Now these molten rocks try to come up on the surface. They try to push always this Earth's crust. Sometimes it breaks, and when it breaks, it come out. The lava oozes out, and you will get what it is called volcanic mountain. Okay. The process is volcanism, but the feature that we get is volcano. Okay. This is volcanic mountain. Now, for volcanic mountain, the material, the rock material which is required, which is coming from inside of the earth. Okay, inside of the earth. So the rock which we get after this is what type of rock? Igneous rock. Okay, so this is primary rock, kind of primary rock. Okay, and mostly this igneous rock or primary rock is basaltic in nature. It is in basaltic in nature, that is basalt. Okay, sometimes it is also granitic in the nature, but that we will discuss. When basaltic in nature, what happens? When granitic in nature, what happens? Okay. Now, when this magma is coming out, at the same time, along with the magma, some other materials also comes up. What is that other material? So the other material is ash. How this ash is formed? This ash is formed because of rock burn. This is also called as a cinder. Cinder. So what is cinder? Cinder is nothing but the ash. This ash is because of the burning of the rocks inside. Okay, so this ash comes out. And then lava. Lava is nothing but molten rock. Okay, when it comes out, it is called lava, but when it is inside of the earth's crust, it is called magma. Magma is when it is inside of the earth's crust, it is magma. When it comes out, we call it lava. Okay. Now, whenever this process starts, whenever this volcanic process starts, initially you will get some form of, like, see here there is a magma chamber, and slowly the magma is rising, it is coming up. Now it is tearing this surface, from here, and magma is coming and accumulating in this area. Okay, magma is accumulating in this area. Now after the magma, sometimes there are also ashes which come out, the burned rocks and their ashes. This is called cinder. So this layer is formed over this magma. Okay, that is its lava. Now it came out, and then ash. So lava ash, these type of repetitions occur over millions of years, because this volcano is not like, it occurred many a time. It is not just formed in a single shot. Okay, so then after lava, again cinder, that is ash. Okay, then again lava comes out after this. Okay, so this kind of structure, that is ash lava, this type of structure is called as a composite volcano. Composite volcano. The composite volcano. Why it is formed? It is formed because of alternative eruptions. Eruption after eruption. It is not formed at one go. Okay, and layers of ash and lava accumulates, and we get a mountain. This mountain is volcanic mountain, but it is specifically a composite volcano. Now, what are the examples of this kind of volcano? There are many examples. Now, these examples could be useful in our preliminary examination, right? So, I will just note down what are the examples. Mount Kilimanjaro. Kilimanjaro. Now, this Mount Kilimanjaro is located at the border of Kenya and Tanzania. It is in Africa. Mount Kilimanjaro is in Africa. Okay. Africa is a very hot country. You know better. Because all three lines, that is equator, tropic of Capricorn, Cancer and Capricorn, passes through it. Okay. So Mount Kilimanjaro is near to the equator. Okay. And we know at equator there is a much heat. We'll talk on this later on. But here is Mount Kilimanjaro on the equator, but it is so high, its height is much high, that we get snow caps at Mount Kilimanjaro. Okay, so it is very high. Then we have Mount Cotopaxi. Mount Cotopaxi. Mount Cotopaxi is located, or it is the second highest peak in the world. After which mountain? Mount Everest. So Mount Cotopaxi is the second highest. It is located in South America. Mount Cotopaxi is located in South America. Then, where it is located, Mount Cotopaxi? Today you just, Rajita, have you got this atlas?
Yeah, I have it.
You have it. Okay. So just check all these places, because these are
Andes, right?
important. Okay.
In Andes it is.
Yes, it is in Andes. Here you will find Mount Cotopaxi. Right?
Chile.
This is South America.
I think if I'm not wrong, it's Chile, right?
Yes. Mount Cotopaxi. Then you have Mount Fujiyama. Mount Fuji, Fujiyama. It is in Japan. Mount Fujiyama. It is in Japan, and they actually worship this mountain because as a god, and many people trek for this Mount Fujiyama. It is a national attraction in Japan. So this mountain is also volcanic mountain. Then there are many other in North America. For example, Mount McKinley, Mount Whitney, Mount McKinley, Mount Whitney. Okay, so like that. Now again, more important mountains in Europe are मध्ये कोणते आहे माउंट एटना आहे माउंट एटना. These names are important because you will get these names in newspaper also. Sometimes these mountain or these volcanoes get erupted and you will get the news. Mount Etna is located in Italy. It's located in Italy on Sicily Island. Then there is another mountain in Europe that's called Mount Stromboli. Mount Stromboli. Now Mount Stromboli has a unique place. It is located in Mediterranean Sea. Okay, near here. Okay, Mount Stromboli. This is Europe. Okay, this is Mediterranean Sea. So it is located here, and all those ships which go from here, they see that this mountain is erupting. That means this is the land now. Hereafter, the land starts, and that's why Mount Stromboli is called as Lighthouse of Mediterranean. It's called Lighthouse of Mediterranean. लाईट हाऊस ऑफ मेडिटेरेनियन. भूमध्य समुद्रातले एक लाईट हाऊस सारखं काम करतो तो. इट शोज द पाथ टू द शिप्स that now it is a Mount Stromboli. That means this region, Italy's region, has came here. Okay, so it's like, and this can be MCQ type of question, that which mountain is called Lighthouse of Mediterranean. It's Mount Stromboli. Then there is another mountain called as a Mount Vesuvius. Vesuvius, it's again very violent mountain, violent volcanic eruption, Mount Vesuvius, that erupted, and uh, many people and houses got burned down. Villages actually gone under it. Mount Vesuvius. Mount Pinatubo in Philippines. Mount Pinatubo. Pinatubo in Philippines. All these names you will get in a book called G.C. Leong. Okay. In G.C. Leong book, they will give you separate, like 1-2 pages are there. Which mountain erupted when and what happened, the story about it. Okay. Now, another mountain in our side, that is the Southeast Asia, that is Mount Krakatau. Mount Krakatau. Mount Krakatau is located in Indonesia. Okay. And Mount Krakatau was also a violent volcano earlier. When it was erupted, it was violent volcano. When it erupted, it consumed itself. And now only relict mountain is remained. Now a small mountain is remained. Okay. It erupted in such a way that there was like explosion kind of thing, and it blew out its all material. And now what remained is called as a Anak Krakatau. Anak means child of Krakatau. Anak Krakatau. And these are also volcanic mountains and very violent. Okay. So this is volcanic mountain. Now, when volcanic mountains are formed, they have differences. Like what kind of mountain should be formed depends upon what kind of material which is coming out. Material, that is magma. This magma will decide that whether the volcanic mountain will have the height, more height, or it is what we can say, domal. Okay, आता म्हणजे काय, or what is it? So see, magma are of two types. One type of magma is very fluid magma. Fluid, it is very fluid म्हणजे पाण्यासारखा. It flows like water. The fluid means flows like water. And another type of magma is viscous. Viscous is very oily, sticky. Okay, it will not flow like water. When you, it's like shahad, mud, okay, or honey. Okay, when you put it, it will not spread immediately. It will slowly spread. Okay, so this type of magma is viscous magma. Now, viscous magma is there when there is a silica content. Silica content is more in the magma or magma material, so it becomes viscous. When it is fluid, it's very liquidous like water. It flows. When it comes out, it flows like anything, like water. When it happens, when the rock inside it is basaltic. When the rock is basaltic. Okay? Now see what happens when the viscous magma comes out. This is the Earth's surface, the magma chamber. Magma started coming up. Okay? And this is the viscous magma. Now viscous magma came out here. Okay, it will stay here, it will not spread out. Okay, next eruption, it will erupt like this. It will just stay like this. Okay, it will not spread much to the larger areas. It will not spread. Next eruption, it will again increase the height of this mountain. Okay, because it is viscous, it will not spread. So this type of magma will give rise to what? Volcanic cone. Volcanic cone. So these volcanic cones are steep. These volcanic cones are steep-sided volcanoes. Okay, these are volcanic cones. Now, if the magma is fluid, if the magma is basic, what will happen? Suppose this is again a land surface and magma, it is coming out. Now, when it comes out, when it comes here, it will not stay here. It will flow like water, right? So you will get this flat structure, somewhat flat structure. Then next time when it erupts, it again erupts like this. It will give you again a flat structure. Okay, so these are domes. These are not mountains. These are domes or domal structures will get created. Okay, because the lava is basaltic. It is fluid lava. That's why. So the domes are gently sloping. These slopes are what? Gentle slopes. Okay. But here, if the magma is viscous, these slopes are very steep slopes. Why it happens? Because the magma is viscous, it contains more silica. Okay, that's why it is like this. Now, what are the examples of this? Let us see. Again, third type of thing happens in between them. Suppose the magma is not much viscous as well as not much fluid. So what will happen? Magma comes out and it will create a structure like this, a kind of plateau. Okay, kind of plateau like structure will be formed. Okay, and this plateau like structure is called volcanic plateau. प्लॅट्यूला काय म्हणतो आपण इन मराठी?
पठार.
पठार, right. Okay, it's a long plain area. Okay, flattened area, so that is plateau. Example of this type of plateau is what? Deccan lava plateau. Deccan lava plateau is basaltic in origin. It is basaltic in origin, and this is flat land. So we have discussed that yesterday also, today also bit, that this area we have got what? This flood basalt. So in part of Deccan lava plateau, this is Deccan lava plateau. So this is how what? Deccan lava plateau. It is flat extended elongated part, okay, and it is volcanic in nature, so it is volcanic plateau. Okay, now here this type of domal mountains we got because of the fluid lava, right? So what is the example of this? The example is Hawaiian island. Hawaiian island. So let us see where are these Hawaiian islands. This is America, Florida. Okay, islands are located somewhere here. Okay, in the Pacific Ocean. Pacific Ocean. In Pacific Ocean, these islands are located, and these islands are only part of this America's tropics. So if you will be asked that is America in the tropics, yes, some part of America is in tropics. Okay. Right, that through the Hawaiian islands, these are Hawaiian island, these are of USA, America. Here is USA. Okay, now these islands are what kind of islands? These islands are domal type of island. Domal type of island. So what happened in domal type of islands? These islands become like this, flat. Okay? Not just flat, the slope is not so steep. Okay, the slope is gentle. Slope is gentle. Okay, that's why we call it as a dome, like hillock. Okay, आता कुठले mountains आहेत इथं? There are two highest mountain in these Hawaiian islands. One is Mauna Kea, another is Mauna Dua. Okay, these are two peaks in Hawaiian island. Sometimes they come in the news, or you need to know where are these located and what type of volcanic mountains these are. These are domal type of volcanic mountains. Okay, now if the fluid lava comes, I told you what happens. If the fluid lava comes, you will get these domes. But suppose if the fluidity is much more, if the fluidity of the lava is much, then what will happen? This will give the rise of plain plateaus. Now these plateaus are Columbia Snake River Plateau, Columbia Snake River Plateau, or these are examples of this type of fluid lava and fluid lava eruption and subsequent landforms, that is volcanic plateaus. So Columbia Snake River Plateau, Kimberley Plateau, it is in Australia. Why Kimberley is famous? Tell me. Anyone? Why Kimberley is famous? Yes, anyone? Okay, tomorrow you will tell me why Kimberley is
Sir, I
famous. Okay,
think
what things are
diamonds,
mined
right?
from Kimberley? Ah, yes, yes. Okay.
Yeah.
Then we have Patagonia Plateau. Patagonia. Patagonia is in South America. Yes, in Patagonia, you know better that there are two. This is the South America. This is Atacama. It is desert, and here you have Patagonia desert. Patagonia desert. So this Patagonia desert is formed because of what? Fluid lava. Okay? Not desert as such, but Patagonia region, Patagonia plateau is formed because of the fluid lava. Okay. These are some examples you need to remember. So when they ask what are the features, then you can write down what are the features of volcanic mountains. Okay. Now there are many other things also in like for example, intrusive rocks will just intrusive landforms. These landforms that we studied are extrusive landforms. Extrusive that we see from outside. Okay, what are intrusive? Intrusive landforms, not just landforms. We are seeing the mountains. So intrusive mountains. Suppose this is our crust, Earth's crust, and we have magma chamber. Magma chamber. Magma is rising. But what happens? Sometimes magma is not that potential, okay, or that magma is not much enough, maybe because of some reasons it lost its ability to rise further. So somewhere here it gets solidified, somewhere here it gets solidified. Okay, now what will happen? This is again what it, the rock structure, it is solidified rock structure, it is called batholith. Batholith, it is called batholith, and this is magma chamber. Now after some like millions of years, what happens? This land get eroded. So suppose this land is get eroded. Eroded means the surface here, soil, okay, the rock is taken away somewhere. Now what will happen? This part get exposed. Okay, this is remain, this what remains is this only now. Okay, and this batholith is now exposed rock. Okay, this batholith is now exposed rock, and it looks like a mountain, it looks like a hill to us. Okay, so these are intrusive volcanic mountains. Sometimes they come up. When they come up, when this land get eroded, the above structure of this batholith, if it is eroded, then you will get a landform that may be called as intrusive volcanic mountain. Okay, these are also called hypabasal landform. Hypabasal landform. And remember always, and this we will study when we are when we'll see how these fold mountains are formed, etc. You will remember this fact that in every fold mountain, at its base, you will find such big batholiths. Batholith. Okay, such big batholiths are always present in the big volcanic, big this fold mountains. Fold mountain. We'll study what is fold mountain, etc. Just in short time. But remember this, these kind of batholiths. So batholith is a hard rock. It is formed because of magma, this magmatic eruption. Okay, and this magma is not able to come out of the surface. That's why they are intrusive landform. They are intrusive landform or intrusive mountain. Okay, there are other intrusive landforms also. Like for example, this is a land again. Lava is started coming up, but it do not come out suddenly, or sometime it come out. But there are other vines also. This land is bedded land. Bedded land means this land has many layers. Okay, sometimes this magma starts coming up, and this comes up here, and then it spreads like this. It spread horizontally. Okay, this is called as sills. Okay, sometimes the magma starts coming up and spreads like this with some angle. This is called as dike. Okay, sometimes what happens? The magma comes up, and because of the structure of this structure of the bed, suppose this bed structure is like this. So what happens? The magma comes out, and it fills this gap or fills this space. Okay, it takes the shape of this. If it is saucer shape, then what we call it? Locolith. Locolith actually. Okay, sometimes it is like this. The lava is accumulated like this because the vent is here and lava is coming up. It occupies this space like umbrella. So it is called as lacolith. Okay. Sometimes it is lens shaped, like it is very plain, small lens. It's kind of lens. Okay, so it is called as a faccolith. Faccolith, lens type. Okay, these are intrusive landforms that you will study in your G.C. Leong's book. Okay, sills, dikes, laccolith, lopolith, faccolith. Okay, so all these intrusive landforms. Then now you understood what are the volcanic mountains. Okay, cinder cone, volcanic domes, intrusive landforms. Next, we will move to fold mountains. Till here, anyone has any doubt or anything that you want to ask?
सर फॅकोलित नाही समजलं.
Okay, फॅकोलिथ काय आहे? फॅकोलिथ इज लाईक लेन्स. आता जस्ट सी. लोपोलिथ इज अ सॉसर शेप. सॉसर म्हणजे काय म्हटलं मी? एक लाईक अ बशीच्या आकाराचा आहे. ठीक आहे. It has its thickness. It has its thickness, but this you asked faccolith, but faccolith is, suppose there is a this bedded plane is like this. So in these bedded planes, just plain like lens like very thin layer of magma is accumulated. Then we call it as a faccolith.
Okay.
Very thin layer. It's like a lens. That's why its feature is lens like. And this feature is saucer like. बशी सारखं. बशी वेगळी, लेन्स वेगळी. ओके, थिकनेसचा फरक आहे. अगेन
Okay.
Shall we move forward?
Yes, sir.
It's also a sinusoidal. What? Faccolith. A sinusoidal. Which one it is? It's not like sinusoidal and all. We just remember that faccolith is a lens-like structure. Okay, it may go up here also. It may go up here also. It can extend, but its thickness is very thin. Its thickness is very less. That's why it is lens-like. Lens किती sharp असते, छोटी असते. डोळ्याची lens. Like that only. Okay. Yes. Let us see fold mountains. What we have seen just now are volcanic mountains. Now we are seeing the fold mountains. Okay. Now fold mountains always are found in, you can say, range. Fold mountains are always found in range. That means they are not isolated. Not isolated. Okay. आता मी एक थोडक्यात सांगतो, just for your understanding, ki why fold mountains are formed. Maybe Prajakta, you may have gone through this study that how they are formed, but for others, let's see. आणि हे आपण डिटेल मध्ये नंतर बघणार आहोत. It is not part of this study, but later deeply we will understand how these fold mountains are formed. Just for your reference, what happens? Yesterday we see कि whenever there is a compressive forces, whenever there are compressive forces, and these are compressive tectonic forces, okay, compressive tectonic forces, then what happens? The sand material or whatever the rock structure is there, it is getting compressed. When it get compressed, it will get uplifted. It will get uplifted into a mountain structure, a mountain. Okay, and these are nothing but fold mountains. Now why they are fold mountains? Because see, this is the surface of the earth. Okay, just remember that this is a sedimentary rock. Sedimentary rock, because sedimentary rock is what? It is not very hard. So if it is not very hard, see, understand that it is like a chewing gum. Okay, and when you are giving pressure from both the side, what will happen? This will turn into like this structure. Okay, this chewing gum will turn like this. It will bend, and you will get something like this. Okay, so these are nothing but fold mountains. These are fold mountains. So remember always that the fold mountains are formed because of compressive forces first. Second, they are of sedimentary origin, sedimentary rock. gets transformed or gets uplifted to form the fold mountains. Okay. Now you know that sedimentary rock जो आहे हा कसा तयार झालाय, how this sedimentary rock is formed, because there was some primary rock, and because of that, after this primary rock, okay, after this primary rock get eroded, the material, the debris started flowing somewhere else, and it got deposited layer by layer. It got deposited layer by layer, and you will get sedimentary rock after millions of years of evolution. Okay, so this is sedimentary rock. Layer by layer, these sediments gets deposited in some shallow area, in some shallow region, and layer by layer they are formed. Then compaction and lithification leads to this sedimentary rock formation. Okay, now this sedimentary rock is compressed. See, I will just take this sedimentary rock now, and now this sedimentary rock is compressed from both the sides. What will happen? It will turn into like this structure. Okay. Now these were bedded rocks. Bedded rocks means they have layers. So all these layers will also gets uplifted layer by layer, layer by layer. All these things gets uplifted. So you will get this kind of structure. So this is nothing but fold mountain. Fold mountain. Okay, clear? So if you draw here, these are fold mountains. So these fold mountains have their own bedded structures. Okay, these are bedded structures, bedded rock structures. Different rocks are there. Okay, so you may find fossils here, because these rocks we said are fossiliferous. Yes or no? Yesterday we have studied their properties. So sedimentary rocks are fossiliferous. You may get fossils. So Himalayas also have many fossils. Himalayas have fossils in it. Okay. आता हे हिमालयस कसे तयार होतात, that theory we'll see later on. But just understand that we are just seeing the mountain systems. Theories we will see later on. Okay. Now this mountain domal thing is called as anticline. Anticline. This is anticline. So anticline is nothing but mountain, and the valley-like structure is called as syncline. 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 So syncline is a depression. Syncline is a depression, and anticline is a mountain. Anticline is a mountain-like structure. Okay, and always remember the compressive forces. The compressive forces leads to the folding. Compressive forces leads to the folding of these mountains or of the structure. Then you get fold mountains. So what are the examples of these fold mountains? And remember that when these compressive forces are much more, then what will happen? If this compression increases, then you will get again high more height of these mountains. Again, if compression again increase, what happen? The height again will increase. Okay, and not just that, these will start distorting. Okay, so you will get different structures. Suppose this may crumble upon somewhere like this. Okay, there may be increasing fault lines. So that happened in Himalayas actually. So we will get different structures. You will read this in NCERT too. Okay, like for example, this fold. Suppose this fold is there. Okay, these were earlier parallel folds. This is parallel fold. Okay, you can see this symmetry, this part and that part. Okay, A part and B part, we can divide it, so symmetrical. Okay, then if pressure increases more, it may crumble, it may fall down on the ground. Okay, sometimes what happens, the pressure is so high that it ruptures. This fold get ruptured in this at the center, and some part, the half of the part get extended or get thrown in front of it. So it happens like this. So this part remain here, half part remain like this, and the half part goes beyond here, okay, like this, above it. So this type of structure is called as a nappy structure. Nappy structure. It happened because of more compressive forces have distorted the anticlines and synclines. Compressive forces distort, they change the shape of anticline and syncline, leading to this complex structure. So Himalayas today are not like just folds, like simpler folds. No, they are not like this. They are very complex folds which include nappy structures also. These are, there are different names also, like recumbent fold, etc., etc. Okay, not necessary to know all these things, but this is the complex structure of Himalayas. Now, where are these sedimentary mountain, like fold mountains, are located? Okay, so let's see with the examples. This is North America, this is South America, Europe, India, Southeast Asia, China, Russia, Japan, Australia. Okay, so this is our world map. Now, in the world map, just see where these fold mountains are located. So this is the first. These are called Rockies Mountain. Rockies are fold mountains in North America. Okay, so I said these mountains are not isolated. असा एखादा mountain नसणार आहे. These are not isolated. These are always a mountain chains. So this is a mountain chain. Okay, these are Rocky mountain chain. Then in the South America, there is again a mountain chain. This is
Andes.
Andes. Yes, Andes mountain chain. Now above here, like near India or at the north of the India, we have Himalayas. Okay. Then here in America, these are the mountains. These are called Appalachian mountains. Okay. In Australia, east of this Australia, there is a mountain system. What is it? This is Great Dividing Range. Great Dividing Range. This is mountain in Australia, Great Dividing Range. Then in the Russia, east of the Russia, here is a Lena basin. Lena river flows here, and just here is a Lena river actually, and here you have a mountain system. It's called Ural, Ural, Ural mountains in Russia. These are again fold mountains. Okay. In Africa, we have Atlas mountain. Here in Africa, we have Atlas mountain. Okay. In Europe, this part of the Europe, the Himalayan mountain chain continues in Europe. These are tertiary mountain system. Okay, so this mountain system has various mountains like Apennines in Italy. Okay, Alps mountains. Okay, so all these mountains are there in European uh, European continent. Okay,
Sir,
France मध्ये एक आहे त्याच
this sir, one correction. I don't know if it is correct, but the Ural mountain, I think it's west to Russia, right? In between Europe and Asia.
No, actually it is the east of Moscow. That means it is in Russia only. It is in Russia only, but it is east of Moscow. Here is a Moscow, suppose. This blue point is a Moscow. Then east of Moscow you will find Ural mountain.
Okay.
Okay. Yes. Okay. So these are all they're all fold mountains. We will see later on how these fold mountains are formed. But at this moment, just remember there where these are located, what are the names of these fold mountains, what is actually fold mountain. Okay, we have discussed that. Now there are different orogenies. We have seen yesterday that there is a geological time scale, right? Geological time scale, and in this geological time scale we understood that in each and every time period different things happen, different earth structure has changed slowly. Okay, so for example, Archean orogeny. In Archean time, there was Archean orogeny, mountains formation system. Orogeny, Oro means mountain, Geny generation, mountain formation system in Archean time. What was the mountain we discussed yesterday, which formed in Archean time? Archean time is very old time, that is 3.5 to around 2.5 billion years ago. What was the mountain in India?
Aravali.
In India, this mountain, yes, Aravalli mountain. Aravalli mountain range plus Eastern Ghats also. Eastern Ghats. Aravalli range and Eastern Ghats are formed in Archean mountain orogeny. Okay, and these are where, what? Earlier Aravalli mountains were fold mountains. Remember this. Earlier Aravalli mountains were fold mountains, but now they are degraded. They become relict mountains. Relict mountain. Okay. Then there was orogeny, second orogeny. After Archean orogeny, there was Caledonian.
सॉरी सर, मला एक क्वेश्चन आहे. सो आपण बघितलं की हे फोल्ड माउंटन इज from sedimentary rocks or like sedimentary structure,
Yes.
right? So
Right.
sedimentary is not that hard, like so that it is easy for
Yes.
it to get the force applied and then
Bending.
get it,
Yes.
yeah, bend or lift.
Right.
But Aravali is also
Yes.
sedimentary mountain, is it?
Yes, earlier Aravallis were fold mountain, sedimentary mountain, but after so many years, like see, just 3.5 to 2.5 billion years, this much time, in this much time, they have transformed, they have eroded. Earlier Aravallis, I said yesterday, they were big, very, like, height was beyond like 9 kilometers, which we see in Mount Everest. Okay, but now they have remained like hills only. You just see, these are now just hills, small hills. So that we called relict, a remnant, yes, of earlier Aravalli. Why it happened? Because of erosion. Wind, water will erode this material, erode this mountain. Its height has decreased. Okay.
Okay, I was under impression that if Aravali is, near Deccan Plateau, this is also indigenous and not sedimentary.
No. Now remember, now don't say that this is sedimentary. Now its form has changed, right?
Right.
So now what we call it? We call it relict. Okay.
Okay. But
Even,
in general,
even
indigenous mountains are fold nahi hot ka?
Which indigenous?
Like any indigenous mountains are fold nahi hot. It's only sedimentary.
Actually, only remember, only sediments gets uplifted. आता आपण बघूया आणखी ज्यावेळी युअर डाऊट विल बी क्लिअर व्हेरी सून, ज्यावेळी आपण बघणार आहे ईस्टर्न घाट्स कसे तयार झालेले आहेत. ठीक आहे.
ओके सर.
तर देन युअर डाऊट विल बी क्लिअर प्रिटी मच. ओके. आता दुसऱ्या टाईपची जी काय दुसऱ्या कालखंडात झालेली जी ओरोजेनी आहे, दिस इज कॉल्ड कॅलेडोनियन ओरोजेनी. त्या कॅलेडोनियन ओरोजेनी मध्ये कोणते माउंटन तयार झालेले आहेत? जसे स्कॉटिश हायलँड आहे, स्कॉटलँड मध्ये स्कॉटिश हायलँड्स. ओके. त्यानंतरची जी माउंटन ओरोजेनी आहे, दिस इज कॉल्ड हर्शिनियन. हर्शिनियन ओरोजेनी. त्या हर्शिनियन ओरोजेनी मध्ये काही माउंटेन्स आहेत. दीज आर पिनाइन्स. पिनाइन्स. देन ॲपलेशियन, जो आपण आता बघितला नॉर्थ अमेरिकेमध्ये, ॲपलेशियन. ओके. ॲपलेशियन नॉर्थ अमेरिकेच्या इथं आहे. सो दीज माउंटेन सिस्टम्स आर फॉर्म्ड, आणि ह्या माउंटेन सिस्टम मध्ये कोल सापडतो आपल्याला. सो पिनाइन कोल फील्ड आहे, ॲपलेशियन कोल फील्ड आहे. सो दीज एरियाज लेटर बिकेम, म्हणजे ह्या अलीकडच्या काळामध्ये दीज एरियाज बिकेम इंडस्ट्रियली व्हेरी इम्पॉर्टंट. इंडस्ट्रियल रिजन्स. Why they become industrial regions? Because these regions had फोल्ड माउंटेन्स. आणि आपण बघितले फोल्डिंग होताना काय होते, त्याच्यामध्ये फॉसिल स्ट्रॅप होतात, बघितलं होतं आपण. These fold mountains are fossiliferous. That means they contain the fossils. Now, if they contain fossils, they will have what? They may have this uh, large mammals side or plant material. Okay, and this plant material, mammals, whatnot, the animals, they get transformed into the coal. They may get transformed into the liquid, that is crude oil. Yes, so this is found in these sedimentary rocks. That's why this region is industrially very rich. Now, this fourth type of mountain orogeny is tertiary mountain orogeny, and this is very latest. Tertiary mountain orogeny. Okay, in tertiary mountain orogeny system, which mountains are formed? Himalayas. We have talked yesterday, right? In tertiary period is a tertiary mountain orogeny. So Himalayas were formed, and along with Himalayas, these were the mountain chains we call Trans-Eurasian mountains. Trans-Eurasian mountains. So what are Trans-Eurasian mountains? This Europe. Okay. So these mountain chains all till this Himalayas. So all these mountain chains is called Trans-Eurasian mountains. Okay. Trans-Eurasian mountains. So these are formed in tertiary alpine period. Tertiary period. They are also called as alpine orogeny. Alpine. Why? Because Alps are also there. In this mountain system, Alps mountains are also there. That's why the name is alpine. Okay. And in North America, we have Rockies. In South America, we have Andes. So all these mountains are also tertiary mountain orogeny. So Rockies, Andes, Himalayas, and Alps or Trans-Eurasian mountains, they all are formed in tertiary time. So they are very young mountains actually. They are very young mountains. Okay, tertiary time is just like 65 million years ago. 65 million years ago. So they are very young, and that's why the peaks in these mountain systems are very high. Peaks, because they are not yet eroded. Earlier, Aravalli was very like with a very high mountain, but now at this present date, Aravalli is eroded. But the present system has a new mountains, that is Himalaya is a young mountain. So if it is young, its height is much more. So more like around 9 km its height. So second mountain, that Cotopaxi we talked, it is in South America, Mount Cotopaxi. It is second highest peak. Okay. So what we are seeing is the tertiary mountain orogeny is very latest, very new, and that's why the peaks here or the mountains here are very high. Their height is much more. Till here, any doubt?
No, sir.
Okay. Pratap, Ajinkya, Nehal? No, sir. Okay. No. Okay. So now what happens? The third type of mountain system that we will see. Ask questions if any. Okay. Now, if you think that I am running faster, you can tell me. Okay. We can repeat things. No issue about that. Block mountains. Yesterday we also, we also saw some block mountains or how they are formed. Okay. First we have seen volcanic mountains. Then we saw just now fold mountains. Now the third type of mountains are block mountains. What is block mountain? The word itself indicate a block. So blocks are nothing but the mountain systems formed because of rifting. Okay? They are formed because of rifting or the forces which are pulling things apart. Okay? कसले forces म्हणू आपण? Tensile. Okay, these type of forces leads to rifting, and then formation of block mountain. For example, काल आपण बघितलंय की if this is the rock structure, okay, and if there is a tensile force from both the sides, what will happen? This rock will generate the cracks, or what we call a fault. This rock will generate a fault, okay, and slowly this part, this is suppose A, B, C, the B part may subside because it will get a space and already it is dislocated from this system. So it may subside, and what you get is this. This is A, this is B, this is C, and the B part, that is middle part, may subside. Okay, so this type of system emerges, and it took lot of time, it took millions of years. Okay, this part is called as a graben. It becomes later on valley floor. The subside, or the part which sank, is called graben. The surface of this part is called graben. Okay, it becomes valley floor later on which the river flows. Okay, on these valley floors, river flows. And valley म्हणजे काय? What is valley? Valley is this part. What we see is this conical shape. This is valley. Okay, and these are mountains. And these are block mountains. These are block. It's like a block. That's why block mountain. But this block is also called, there is a word, it's called horst. This is called horst. That's why sometimes block mountain are also called as a horst mountain. Block mountains are also called horst mountain. Okay, what are these examples now? And see, sometimes these block mountains are also formed in the fold mountains also. For example, if there are folds like this, these are fold mountains. Okay, these are fold mountains, and because of some reason, what happens? There becomes a crack. Okay, and now this crack leads to what? Dislocation of this part with this part. So this part may subside. So it seems like this. Earlier this was fold, but this part subsided. So what you will get? This part is a block. Now this part, you can call it as a block type of mountain. So it may be in the fold mountain also. Okay. So blocks can be anywhere. Now what are the examples of these type of block mountains? The example nearby us is what? Vindhyas, Satpuras. Okay, Vindhyas and Satpuras. Where are these located? Vindhyas and Satpuras. These Vindhya and Satpura range are nothing but block mountains. Okay, so block mountains creates the rift. We'll see this later on again. Yesterday we just saw this, what is rift and all. So Vindhyas and Satpuras create rifts. What are another mountains? Sierra Nevada. Sierra Nevada mountains. These are in the United States. Then there are Ruhr or Ruhr mountains in Europe. Okay. There are Black Forest mountains. Black Forest. These are in Germany. Okay. These are in Germany. Now these are very important. Okay. Why very important? Because whenever there is a block, just remember, whenever there is a block, so something has fallen down, something has gone inside. So earlier this part may have forests. Okay, this part may have forest. Now these plants also go inside and they get buried in this area. So after hundreds and millions of years later, you will find that this part or this thing turned into coal. Okay, so these Black Forest or Ruhr Valley, you will find coal resources, coal deposits. Even in India also, Vindhya Satpura ranges, in these areas you will have coal deposits of India. In this area you will have coal deposits. Why is it so? Because of faulting.
Chota Nagpur
Okay.
Plateau.
Yes, Chota Nagpur Plateau.
Actually, Chota Nagpur Plateau is called Ruhr of India.
Ruhr of India. Okay, this is very important fact then. Chota Nagpur Plateau, the Ruhr of India. Good. Okay. Now we move forward. This rift is again seen in one area which is prominent, and that area is Eastern Africa. Okay, so this is Africa. This is Africa, and this part of Africa, the eastern part of Africa, what we have, it's called Great African Rift Valley. This is called Great African Rift Valley. So why it is Great African Rift Valley? It is because what is happening here, this area or this land is moving here, and this part, eastern part of the African continent is moving here. So there is a tension, and this tension led to the fracture of Africa. So this fracture that created this type of valley here. Okay, if we take the cross section of this cross section is like this. Okay, and this valley is called Great African Rift Valley. Understand? Now in this Great African Rift Valley, you will find many volcanoes also. That we'll study later on. Okay, why volcanism is there in Great African Rift Valley. Okay, how it is formed. But at this moment, just remember, Great African Rift Valley is also a block type of mountain system. Okay, it has formed there. Now, जे विंध्यास आणि हिमालय, विंध्यास आणि सातपुरा जे आहेत, okay, here you are Vindhyas. Okay, then you have Satpuras. After Satpura, you have Satmala and Ajanta range. Satmala and Ajanta. Satmala, Ajanta. Now these are these are block mountains. Okay, these are ruptured. These are tensed. This region was stretched and led to what? Block mountains. Now these block mountains, they create what? Rift valley. We have studied. In these rift valleys, we will find that many rivers flow. So what are these rivers? Example, Narmada river. So Narmada flows between Satpura and Vindhya. It's like this. Here, I'll just take a cross section. If you take a cross section, you will find this one mountain, then another mountain, then another mountain. Okay, so this is suppose Vindhya. Then you have Satpura. Then you have like Ajanta or Satmala. Now, in these mountain ranges, between these mountain ranges, you will find the river systems. For example, between Vindhya and Satpura, you have Narmada. Between Satpura and Ajanta range, you have Tapi. Okay, so these are what? These are the rivers which are flowing at the graben region, at the bottom of these block mountains. Okay, graben or these valleys which are created by these block mountains. Right? Now, हे block mountains इथपर्यंत कळाले आपल्याला. If we go forward, there is a fourth type of mountain system. This fourth type of mountain system is created because of escarpments. Escarpments. What are these escarpments? तर या शब्दामध्ये आहे, this word itself indicates scarp face. Escarp, that is scarp face. What is scarp face? The scarp face means the face or the steep slope of anything. The steep slope or the face, that is called scarp face. And because of this scarp face, we will get a steeper slope, relatively steeper slope, and that we call escarpment. Okay. Now these escarpments are formed in different region because of different phenomena. For example, if there is a block mountain, for example, this is a plateau and it has developed because of block or fault. Okay. And this block mountain has its face. So this face is very steep. This face is very steep. This can be edge of plateau. Edge of plateau. This can be edge of plateau. For example, this is Chota Nagpur plateau. Suppose this is Chota Nagpur plateau. Now, Chota Nagpur plateau has its edges here. Here we have Raj Mahal hill. Okay, and at the this side, that is southern side of it, we have Garjat hill. So in Chota Nagpur plateau, these are the edges. So these edges turn into the escarpments. It's like mountain. Okay, it's escarpment. It's like mountain. So these are called as these type of mountains are called as a escarpment type of mountains or escarpments only. Okay. Now, what are the other examples of these escarpments? Western Ghats. So Western Ghats is nothing but escarpment. So what happened? Why Western Ghat become an escarpment? It became escarpment at the time of around 60-65 million years ago again, when the Himalayas were forming. So what happened at that time? The eastern part, the western part of India, this Indian peninsula, the western part, this part got detached, cut, okay, and gone down into the ocean. This western part got detached because of the fault. This fault is created, and because of this fault, this area, this was again a land, this is extension of the land, this area gone down. That means it went inside the ocean. So what happened? Okay, so this phase remained, and not just gone down. This is gone down like this. So this was the area which gone down. Okay, and now you have this face which is very steep. Okay, and when I stand here, when I stand somewhere here, if I look up, what happens? I can find a big mountain wall in front of me. This seems like a mountain wall. And where I am standing now? I am standing in this coastal region of India, western coastal region. It may be called in Maharashtra Konkan. Okay, if I am standing in Konkan region and if I look upward here, eastward, I will find this big face in front of me. Now this can be escarpment, and these are Western Ghats. So Western Ghats are nothing but what? These are walls, these are escarpments. Now when this event was happening, when this faulting and then subsidence was happening, the Indian plate turned like this. ही स्लिप झाली, इट टर्न लाईक दिस, आणि त्यामुळे काय आहे, याचा जो स्लोप आहे, दी स्लोप इज लाईक दिस. When plate turn like this, so its slope is like this. You understand? Just clarify again. Okay. So when this was broken, this part was broken, the Indian plate turned here. Okay. That means its slope is in now this direction. Okay. The slope is in this direction, and that's why all the rivers which were flowing on this land started flowing from west to east. These rivers started flowing from west to east in Indian peninsula. For example, what are these rivers? There are exceptions though. We'll talk about that. But there are rivers like Narmada River. Then no, not Narmada. We have Godavari River. Yes, we have Krishna River. We have Kaveri River. Okay, so all these rivers started flowing from west to east. It is because of tilting of Indian peninsula. Indian peninsula and it's tilting. Okay, so this was an event. Now, where are the other mountains where we can find this kind of escarpment? Example is Altai Mountain. Altai Mountain. These Altai Mountains are located in Mongolia, Mongolian plateau. They are also like Western Ghats. They are also escarpments. Okay, they are also escarpments. Now, where are other regions in India where these kind of escarpments are formed, but due to different reason. So different reason can be erosional escarpment or erosional reason escarpment. Erosional escarpment. So what is erosional escarpment? Suppose there is a plateau. Okay, there is a plateau. On this plateau, you have rivers. Okay, now there are rivers over this plateau. Slowly, what happens? These rivers start eroding this material on this plateau, and this plateau gets divided, gets dissected into different hillocks or hills. Now this was only one plateau. Now we can find that there are three different hills because of these rivers. Okay, if there are two rivers, then it happened like you get different escarpment plateaus. Okay, this happened where? This happened in Meghalaya plateau. So this was a Meghalaya plateau, and Meghalaya plateau got eroded because of rivers, and these rivers are like Kopili, Dhansari, and we will get what? Garo, Khasi, and Jaintia. So all these hills, that three hill ranges, are basically where the part of a single plateau, Meghalaya plateau, but later on this plateau was divided into different hills like Garo, Khasi, Jaintia because of erosional nature of the rivers, or these rivers eroded them. Okay. Any doubt in this? Now, escarpments can also be because of the intrusive rock systems that we have. Okay. Intrusive rock systems. What are intrusive rocks? Just we have seen there are sills and dikes. So what happens sometimes? This is the land from outside. Okay, this is Earth's crust. But inside, what happened few million years ago? Suppose there was a volcanic eruption from inside, and the volcano led to formation of this kind of dike. This volcanic lava came out and it went angularly like this. Okay, and it solidified. So this is a big rock structure inside the Earth's crust, solidified rock structure. We called it as a dike. Okay. Now, after some years, what will happen? After some millions of years, this structure got eroded. This structure got eroded, and this part gets exposed. This part gets exposed. So this dike gets exposed. When the dike gets exposed, what you will find? You will find this sharp face. Okay. So this sharp face is again a escarpment, and it seems like a big mountain. Seems like a big mountain. So this happened because of the dike getting exposed. Okay. Sometimes hills get exposed. What is sill? Suppose this magma is coming out and magma spread horizontally. Okay. Magma spread horizontally. Yes, there was a rock structure above it. Now magma spread horizontally, and then later on what happened? Erosion, and again this area get eroded, and this sill is exposed. Now this sill is very big. This face of the sill can be escarpment. If you stand here, this is so big actually, this much. Okay, if you stand here, if you see to this side, you'll find this face, and this face can be very steep. That's why escarpment. This can turn into a mountain. Okay, now we have seen above that Meghalaya plateau is formed like this. Meghalaya plateau again an escarpment. Okay, but there we find, or in some areas, not in Meghalaya, but in some areas, what happens? The hard rock overlays the soft rock. This is soft rock, and it is capped by the hard rock. Is capped by the hard rock. Now, slowly what happens? Due to erosion processes, this hard rocks gets eroded. Okay, beneath there is a soft rock, so it is very prone to erosion. But because of this hard rock, this below structure remained intact. But slowly what happens? This hard rock gets eroded, and it leads to what? Formation of this type of structure. Soft rock at the bottom, hard rock at the cap, or hard rock at the top. So these are this first structure. This is called as a mesa. This is called mesa. Now this structure, the second type of structures, are called as BUTTES, butte. Okay, mesa, if divided or dissected, then it leads to butte. And if the butte further eroded, what we will get? We will get pinnacles. We will get pinnacles. And at the top of the pinnacle, what you have? At the top of pinnacle, you have hard rock. But at the bottom, you have soft rock. Or majority of this mountain has a soft rock, but at the top you have hard rock. So when you see this kind of structure, you should imagine that earlier this should be a mesa. This mesa may be eroded into buttes. These buttes lead to the pinnacles. Pinnacles are like conical shaped mountain which has hard top. Okay. So these are pinnacles. Clear? Till here, anyone has any doubt? Let me drink some water. Sometimes what happens? Sometime in the volcanoes, okay, when the volcano is formed, okay, the lava start coming out to the vent. This is called as a vent, okay, or conduit. Through conduit, it's like a pipe-like structure. Okay, from this pipe-like structure, the lava is coming out and it is spreading. It is forming the volcano. Now see, suppose this volcano is extinct, means this conduit, this pipe which had a lava material inside it, it is also now solidified. It has turned into the rock. After millions of years, what will happen? This structure you will find like this. Inside of it, there is a hard rocks. Okay, this type of structure. It is very hard actually. This inside structure becomes very hard. Okay, it is called as a diabeams. Okay, or other name is volcanic plug. Volcanic plug. Now what happens? Volcanic plug is always very harder as compared to the outside rock. Okay, they are very harder as compared to the outside rock. Slowly, what happens? The outside rock, which is softer, leads to more erosion. So the volcanic plug remain as it is, and other material got eroded. So this start eroding faster, but the volcanic plug remain intact. Okay. Now this volcanic plug again can be called as escarpment. Okay. This volcanic plug is again itself become a different type of mountain. So these are escarpment type of mountains. Okay. The example of this we can find it in the Wyoming in USA. Wyoming in USA. There, this type of mountain is called as a Devil's Rock. Devil's Rock. Okay. So this Devil's Rock is nothing but a volcanic plug. This volcanic plug is transformed into this mountain. Now, the last type of mountains we see, I think it's fifth. These are residual or relict mountains. Residual or relict mountains. Okay. So remember always that हे आपण आयसोस्टॅसी मध्ये पण बघणार आहे. दिस प्रिन्सिपल विल सी इन आयसोस्टॅसी. ओके, whenever there is a formation of hill, mountain or something, okay, somewhere there is a depression or somewhere there is a what we can say एका साइडला ज्यावेळी काहीतरी प्रेशरनी काहीतरी फोर्सनी if things gets uplifted, somewhere there is a warping or downgradation of the land. Okay, warping happens. Okay, तर ही एक हे आपण आयसोस्टॅसी मध्ये बघणार आहे. दिस इज अगेन बिग टॉपिक पॉइंट, आयसोस्टॅसी. But at this moment, remember this, that because of these mountains, big mountains, the earth tries to reduce their height always. Why earth tries to reduce? Because this balance, this A, B, they need to be balanced. Somewhere there is a upliftment force and somewhere there is a this force getting this compensated. Okay, so for that what happens? The rivers gets their energy. And rivers always do only one thing, that is erode this mountain slowly, erode this mountain and make it to the ground, because to achieve the isostasy, to achieve the balance. Okay, so slowly every mountain, you see, this will slowly degrade, this will slowly reduce in its size, and they become residual or relict mountain. Okay, that is the phenomena. We'll see later on what are the functions of the rivers and how they do it, how they make this system happen in detail. Okay, so what are the residual or relict mountains for this at this moment? As an example, Western Ghats, not Western Ghats, Eastern Ghats. Eastern Ghats. Then Jolen Mountains. Okay, so these are some examples of residual or relict mountain. Even our Aravali is an example of residual mountain or relict mountain. Okay, so till here, these are what we have seen today is the features of mountain systems. Okay, tomorrow we will again see some part of valleys and depressions and more features. Okay, and then after understanding all these terms, we will start our theoretical part, that is theories, and in those theories these words will come up again and again. Okay, so shall we, any doubt, anyone has any doubt till here? Yes. So what you people should do every day I will share these PDFs with you. Every day just look at these diagrams, just look at the names, read these names.